Common ion effect. Common ion is an ion that is common to one or more components in a mixture of a solution of ions. Common ion effect is the reductions in the solubility of salt in the presence of a common ion. So let's say if a soluble chloride salt such as sodium chloride is added to saturated solutions, AgCl solutions, let's see the equations first. So as we know that AgCl will produce Ag plus and Cl minus. So when you add an ACl into AgCl, NaCl will produce Na plus and Cl minus as well. So AgCl produce Cl minus, and NaCl will also produce Cl minus. So the common ion here is Cl minus, that is chloride ion. So this picture shows the effect of additions of sodium chloride into the saturated AgCl. So as we know that in AgCl solutions, in the saturated AgCl solutions, it already has Ag plus Cl minus. So when you add an ACl will produce Na plus and Cl minus also. So what happened when you add an ACl into the saturated solutions? It will increase the concentration of Cl minus, the chloride ions. And according to Le Chatelier's principle, when concentrations of chloride ion increase, the system will try to decrease concentrations of chloride ion by shifting the equations to the left. So since the equations shifting to the left, more AgCl precipitate form and the solubility of AgCl will decrease, so it will become less soluble. So the conclusion here, additions of Cl ions reduce the solubility of AgCl. So this is the effect of common ion. It will make the salt less soluble. So here's another example to show the effect of common ion. So let's say that PbCrO4 saturated solutions that consists of Pb2 plus and CrO4 minus. When you add lead nitrate, PbNO32, into the saturated solutions of PbCrO4, what's the common ion here? The common ion here is lead ions, Pb2 plus. So the concentrations of lead ions, Pb2 plus, will increase. So according to Le Chatelier's principle, lead ions will combine with chromate ions in solutions to form additional solid. So the system will shift to the left to produce more solid. And the salt become less soluble. Silver chloride AgCl would be less soluble in A, 1 molar HCl, or B, 1 molar NaNO3, or C, 1 molar zinc Cl2, or D, 1 molar AgNO3. So here you need to find out the common ion first. So if let's say 1 molar HCl is added to AgCl, the common ion here is Cl minus, which is chloride ion. So it will reduce the solubility of salt because of the common ion effect. But let's look at another choice. If let's say B, 1 molar NaNO3 is added to AgCl, there's no common ion here, so it will not change the solubility of silver chloride. There is no effect on the solubility of silver chloride. For C, if 1 molar zinc Cl2 is added to AgCl, the common ion here is Cl minus, which is the chloride ions, so it will also reduce the solubility of silver chloride. And for D, 1 molar AgNO3 is added to AgCl, so the common ion here is Ag plus. So it will also reduce the solubility of silver chloride. But which one will make this salt less soluble? The answer is C, because this salt, ZnCl2, produce 2 mole of chloride ions. Consider the following solubility equilibrium. SrF2 produce Sr2 plus 2F minus. So the equilibrium will shift left upon the additions of A, H2O, or B, SrF2, or C, CrCl2, or D, Na, NO3. So the answer here is C, SrCl2, because the common ion here is Sr2 plus. Identify the most soluble sulfide. So remember, in order to find the most soluble salt, we need to look at its Ksp value, right? Keep in your mind that the higher the value of Ksp means that the bigger the value of Ksp, the higher the solubility of salt. So from these choices that we have here, which ones of this salt is the most soluble? So the answer is D, as the Ksp value is 2.3 times 10 to the minus 13. It has the biggest value of Ksp, so it is the most soluble salt compared to the rest of salt.